the molecule. Size of the molecule. Okay, so size of the molecule means, you see, there are to measure, see, a very, very small distance, the size of the molecule will be, usually it will be of the order of 10 power minus 8 meter to 10 power minus 10 meter. Okay, the actually size of the molecule used to be, that is size with the diameter. Okay, therefore 10 power minus 8 meter to 10 power minus 10 meter. Okay, therefore you cannot use the ordinary optical microscope, okay, to find out the size. Okay, you cannot. Why? Because the optical microscope means it uses, after all, it is light. What is the wavelength of the light? Visible spectrum. Visible spectrum varies from, actually, from ultraviolet to not ultraviolet, violet to red. Okay, that is only visible now. Therefore, violet means it is 4 into 10 power minus 7 meter. Okay, 400 nanometer to maximum of it may go to 8. 8 or 7. 8 also, it is around 7. Okay, so 7 into 10 power minus 7 meter. Okay, therefore, wavelength. Okay, therefore, you cannot use this optical, what is a light? Okay, because usually you are using optical microscope, means only light is used to what is a magnify, because for a convex lens we are using objective, eyepiece, everything we are using just to magnify the object, right? Therefore, but what is the criteria if you want to magnify the object? What is the criteria here is the size of the object should be comparable to that of the light, what you are, wavelength of the light, what you are using. But here, wavelength of the light here is of the order of 10 power minus 7 meter, but the size of the molecule is still, it is less, 10 power minus 8 to 10 power minus 10 meter. Therefore, definitely, you cannot use optical microscope because the resolution is very poor. You cannot see the molecule. You cannot estimate the size of the molecule by using ordinary optical microscopes. Okay, therefore, what can be done? That is, I think already I told you, there are some microscopes, what is electron microscopes. Okay, electron microscopes, it uses the electron stream of electrons. Okay, moving electrons, and moving electron, it acts as a wave because it is what is called de Broglie wave. It is a matter wave. Even particles, when moving particles act as a wave. Okay, therefore that is given by de Broglie. That is why the wave is what is called de Broglie waves. So moving electron acts as a wave. Therefore, electron wave it has the wavelength of the order of I think it is 0.6 in 10 power minus 10 meter around. Okay, therefore I think it is very less. So you can use, when compared to the wavelength of your light, visible light, the wavelength of the electron here, moving electron, not electron. When the electron is at rest, it won't behave as a wave. It is a particle only. When it moves, then it behaves as a wave. Therefore, the wavelength of electron is of the order of, moving electron is of the order of 0.6 in 10 power minus 10 meter. So it can be used to find out the molecular size, that is by using electron microscope, and there are very tunneling microscopes are there. So these are all meant for viewing, because the resolution is very high. Therefore, you can very nicely view the molecule, and hence you can even find out the size of the molecule to a certain extent. But they are all costly. Okay, therefore, labs like school labs you cannot afford. Okay, the electron microscope and all. So, what is any other method so that we can comfortably measure the size of the molecule in our lab itself with a very minimum what is that money spent. Okay, therefore there is no need for going for hi-fi equipments. So what can be done? So there is one method. What is that simple method for estimating the molecule or molecular size of what is called oleic acid? Okay, oleic acid. What is oleic acid? Anyone is having idea? I don't want this color. What is Oleic acid. Oleic. Any idea for that? For you about oleic acid? Oleic acid is nothing but it is actually why you have taken oleic acid here is it has comparatively it has what can you say, size is bigger. Size, okay. Therefore, you can say that it is just like oleic acid means just like a soapy liquid, okay. And the size is of the order of 10 power minus 9 meter. So, therefore, you can easily you can even find out in our lab, okay, the molecular size of oleic acid. Okay, how we are going to see. Therefore, size of oleic acid, how to find it. Actually, oleic acid is nothing but I thought you know. It monosaturated omega-9 fatty acid it is. Okay, therefore, which is the best source for oleic acid is olive oil. Okay, olive oil. So it is very good for health also. Olive oil means, you know, no? So olive oil is the best source of oleic acid. Anyhow, so that its molecule, why we have chosen? Because its molecular size is slightly bigger. That is why we have chosen this oleic acid molecule, and we are going to find out the size of the oleic molecule. Now, oleic molecule, what is the formula? Is C17. Okay, this acid. C17H32COH. Okay, this is what is called oleic acid. And now how to find out, how to measure the size of the oleic acid molecule. Now we are going to start, right? First, see, as I told you, the range of the size of the molecule is 10 power minus 19 meter. So, what are all, what we have to do to find out? But we are going to measure the size of the oleic acid in the lab, okay? Therefore, even in school lab we can, okay? What is required here? I'll tell you. See, take, I think you have idea about pipette. You have idea pipette? Pipette have you seen in the chemistry lab? Have you, children?
No, ma'am.
No, pipette. You have not seen. Okay, in that case, I have to show you. Next class, I thought you would have seen. Pipette is meant for if you want to take, say for example, I want now 1 cc of oleic acid. 1 cc, centimeter cube, volume. Centimeter cube means what is it? It is volume. Correct. 1 cc of oleic acid I want. How to take this much small volume? For that only, whatever you can use the pipette. Okay. Therefore, take 1 cc of oleic acid first. Steps. Okay. Properly, you just concentrate here. Take 1 cc, only 1 cc of, okay, oleic acid. Okay. Right. And mix it with alcohol. Mix it with alcohol, okay, to prepare 25 cc of solution. Mix it with alcohol, you can say. Mix it with alcohol, okay, to prepare 25 cc of, what is that? Solution. What is the solution? Solution now, it is a mixture. Mixture of oleic acid and alcohol. Therefore, 25 cc of solution. Okay, first step. This is the first step. Take 1 cc of oleic acid. Okay, therefore, and mix it with alcohol so that a solution is made. Okay, how much to prepare a solution of 25 centimeter cubes, 25 cc of the solution. First step. Okay, this you can easily do in the lab. Okay, right. After that, the solution is ready. Okay, now what you have to do, from that solution, 25 cc of solution is with us now. From that solution, take 1 cc of that solution. Once again with a pipette. Okay, 1 cc of the solution and mix it once again with alcohol. Are you following? See, mix it. This from this 25 cc of solution is ready with you. From that, once again, what are you doing? Take 1 cc of that solution. And once again, you mix it with alcohol in order to prepare. Take 1 cc of the above solution prepared. But already it is ready now. Okay. Above solution. Okay. Mix it with alcohol. Once again. Mix again with the alcohol. Okay. So as to prepare how much? To prepare 20 cc of solution. Okay. So now therefore, now you see very important. First I have taken only 1 cc of oleic acid. That's it. We need that oleic acid. We are going to measure the size of the oleic acid and how much is required. Only 1 cc. That's it. Okay. 1 cc of oleic acid. Take it, mix it with 20, even 25 or 20, whatever you want. That, but you have to calculate. That's it. 25 in your book, I think it is 20 cc is given. Whatever is that, doesn't matter. But only you have to be very careful here. Anyhow, that is 25 or 20. What you have to do here, it is 26. The calculation must be properly done. That's it. Okay. Mix it with alcohol to prepare 25 cc of the solution, right? From that you take once again 1 cc. Then once again you mix it with alcohol so as to prepare 20 cc of the solution. Right. Now my question, all of you. Anyone I'll ask. Be ready. Can you give me the concentration of oleic acid in this solution now? The solution which is prepared now. The solution is ready now. Okay. In this final 1 by
25 into 25 cc.
25 into
25 cc.
25 into 20 said 25 and 20 cc is the total solution. Okay, by what I want is the concentration of what I want in that solution, prepared solution. What is the concentration of oleic acid? Concentration of oleic acid. I think somebody told oleic acid. Okay, in alcohol. Maximum alcohol is only there now. Therefore, what is that? It is nothing but 1 by
400.
25 into 20 na 500. Correct? Are you following? 1 by 500. That is only concentration. Are you following? Concentration of oleic acid in alcohol is only 1 by 500 of the solution. Correct? Of the prepared solution. Okay. Once it is known, now what you have to do? See, actually, I just want to show it to you one thing. Where is it? See, this is the oleic acid molecule. Okay, size, just I wanted to show you. Okay, this is the structure. And now what you have to do now? I have not used lycopodium powder. Anyhow, no problem. See, what you have to do, take a trough, take a trough of water. Okay, now we are going to start. Once the preparation, the whole 1 by 500 solution is prepared. Okay, therefore now what you have to do, oleic acid solution is prepared and oleic acid solution in alcohol is prepared. Now what you have to do, you have to take a trough of water. Okay, large, let it be a large trough. Okay. Now, in that, what you have to do, I'll tell you, see, you have to nicely sprinkle, okay, what is called lycopodium powder. Like, actually, I just wanted to show the image. It is a yellowish powder, okay, lycopodium powder. Whatever, just you have to sprinkle on the water. You take a trough of water, okay, like this, and you just sprinkle lycopodium powder on it. Why? Because lycopodium powder nicely float on cold water. nice. It will just to prepare a surface. Just to prepare a surface. Therefore, you will be getting a surface yellow color, light yellow colored surface. Okay, is made on water like that. Just to prepare that. Okay, what you have to do, you have to sprinkle. That is why you see here it is given. You see lycopodium water surface. इसमें दिया है ना lycopodium. Therefore, now this you have to sprinkle it. Okay. After sprinkling, what will happen? Nicely, it will form a surface. Nicely, it will float on water. So you will be having a surface of lycopodium powder on water surface. Okay. Now, next one, what you have to do? Take a pipette. Okay, and pour n drops of this solution. The solution you have prepared, no? Whatever solution you have prepared, you take n drops of this solution, okay, and of volume, okay, solution n drops of the this solution, okay, and each of volume that is equal to V. Each drop is having volume V. N drops of solution, take. Okay, it is fourth one. Solution, okay. And what you have to, each of volume. What is the volume? Each of volume is V. Volume of each droplet, each drop, okay, is V. Okay, like that you have taken. Pipette, if you see, no, you will come to know. Just like that, you have to take some solution and you have to slowly, what is the, immediately you can see what is the volume you have taken from the pipette. See, readily you can measure how much volume you have taken from the pipette. Okay, next class I'll show you the image of pipette anyhow, if you want, if you are interested. Okay, anyhow, so what you have to do is, you have to take certain very small volume of the solution with a pipette, and just you drop it on this lycopodium surface, that is on water surface. Drop it. While dropping, you count how many drops you are pouring. Okay. Therefore, how many drops you are pouring is n drops. Okay. Therefore, whatever very small amount only you have taken, how much volume you have taken, you have a note of it. Okay. Therefore, now what you have to do, you have to drop that solution slowly on the surface, okay, of water. Therefore, while dropping, you see how much drops, 1, 2, 3, 4, like that, you count it. Therefore, how many droplets are there now? N drops you have counted. Okay, and each of volume V, that you don't know. How much? What is the volume of each drop? You don't know, but how much volume you have taken, you know. Initially, you have very slight amount of what is that solution you have taken from the through the pipette. So readily you can very well find out what is the volume readily from that will be measurement on the pipette. So you know. Therefore, from that, how many drops you are pouring? The fully, very small value you have taken. So pour. How many drops? Fully, or whatever solution you have taken, just you pour it on the drop of water on the surface, lycopodium surface. Okay. And while doing so, you just count how many droplets are dropped. Fully, you just empty that. How much small amount you have taken, empty that. How many droplets are there? From that, I think you know, if you take, as I told you, if you take each volume, each drop of volume, that is V. Okay. Like that, how many droplets? N droplets. Therefore, what is the volume of N drops of the solution? That you can readily find it from the pipette. I told you know how much you are taking. I was taking very small amount. Okay. And that is nothing but volume of N drops of the solution. Okay. That is equal to N into V. Hope you are following these two steps. Okay. First you take a very little amount. Okay. What is the volume? You just see that volume is nothing but NV. That volume is nothing but NV. And after that, what are you doing? You are pouring it on the surface, that is lycopodium, that water surface. Once you're pouring, just count how many droplets you are pouring. Therefore, total volume is NV. And how many droplets you are pouring? N. Therefore, what is the volume of each droplet will be equal to NV. Is it clear? Sorry, volume is equal to V. Hope you're following this. Anyone can you explain this? What I have told now? Anyone? Are you here? Children?
Yes, ma'am.
They explain.
Ma'am, when we take one, we have to take 1 cc of folic acid and
Not
mix it with.
no, that you leave. From this only I am. That I think I have idea. Here I think.
Ma'am, in that equipment that we are taking, the n drops of solution, if we are taking 4 drops of solution, we have to multiply with the amount of volume we are taking by seeing in that instrument. That will give you the total volume of the solution you are putting in that trough, ma'am.
Yeah, I think you are able to understand. You cannot directly measure what is the volume of each drop. Correct? You cannot. That is why you take very little amount in the pipette. Okay. Then you drop it. How many drops you have an idea. Therefore, n drops have the volume of NV. Therefore, what will be the volume of one drop? Are you following? That is equal to. So you can find out, right? Therefore, what is, I think you are able to understand. And we maybe, what is that? Very, very small, 5 cc, 10 cc, like that. Yeah, that readily you can measure from the pipette, whatever amount you have taken. Okay, therefore NV is known. So you can read it from the pipette value, from the pipette readings. Now, once you know this, now what is, my question is now, what is volume of, okay, oleic acid in this solution? What is the volume of oleic acid in this solution? Can you tell me? NV is, what is that? Whatever, this much is poured there on the surface. Therefore, how much volume of oleic acid is there? Total is N. Whatever you have poured. Volume of N drops of the solution, whichever you have
NV by
poured on.
500.
Yeah, NV by 100. This is your poured here. Oleic acid, see. Okay. Therefore, what you have to do, how much it is NV by 100. NV by 500. Are you following? So this is the volume of oleic acid in the solution. First, you keep this one as equation number 1. Okay. Now come to this part. See here. Once you are, that is, see here. Okay. Here, alcohol, once it is poured, yeah, you are lycopodium surface. Why? Because it should be visible. Yeah, whatever you have poured, in oil, it should not, it won't spread properly. Okay, then water, so that you should know, it should be visible to you. That is why the contra you should have. That is why lycopodium yellow color powder you have spread it, you have sprinkled there, and on the top of it you are pouring, okay, n drops of the solution. And once you are pouring, what happens? It will spread. As it spreads, what happens? The alcohol, you give some time, alcohol immediately, it the solution of this nicely spread on the surface of water. Okay, and it forms roughly a circular film on the, see here it is given now, roughly it forms some circular film like, okay, on the top of oleic acid. Lycopodium, I didn't dealing with lycopodium surface. It is not oleic acid. Oleic acid, it is a solution. In the solution mix, lycopodium surface. On the lycopodium surface, it is yellow in color, and on that you are pouring. Once you pour, immediately that solution spreads on the surface. Lycopodium on water surface. There it nicely, it spreads. Once it spreads, Okay, approximately it will be circular in shape. Okay, now if you leave some time, immediately what happens, alcohol immediately it evaporates. It evaporates nicely within no second. Once it evaporates, once it is poured, then it evaporates. Once it evaporates, which is there, what is left over in the film now? Only
Oleic acid.
Oleic acid.
only oleic acid. Are you following? So this much you have to take. Only oleic acid layer is left on the water surface. Okay, now our job. So the thickness is very, very small. The surface, on that surface, the oleic acid spread, the thickness of that surface, oleic acid spread is very, 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 very small, which is of the order of thickness is 10 power minus 99 meter. That is, the thickness is approximately equal to the size of the molecule. One molecular thickness of oleic acid only is spread on the surface. Okay, therefore now we have to find out the thickness of that layer. Thickness of the oleic acid patch is there, that layer you're finding the thickness. Once you find the thickness of that layer, that gives you the size of the oleic acid molecule. Therefore, what to be done? Either there are two methods. First, you have to find out the spread, area of that spread you have to find out. Okay, so area of the spread, let it be A. How to find, I'll tell you. And thickness of the spread is T. The thickness only is your molecular size. Okay, area into T, that gives you what? Area of the spread वो circular है ना इसमें. Let me use
Volume.
okay. It was the circular, approximately circular patch. Okay, so area is known. Area you have to find out, and thickness is not the thickness of that layer of oleic acid. Okay, that is equal to the molecular size. Very, very minute film will be there. Therefore, now what is the volume of the spread will be A into T. Okay, now our job is to find out A. How to find out the area of the spread? It is very, very, very small patch. So when either you can use the area occupied by the oleic acid by using microscope. Okay, powerful microscope. Once again, going for powerful, if not, what you have to do? There is one more method. Take, I think you know that the transparent butter paper like that, that oil sheet. Okay, just you spread it here. Once you spread that oleic acid patch, it will be properly. What is that? No, you can see. Once you just keep that, what is a butter paper or oil sheet? You just keep it here. Okay, therefore you will be able to see the patch there. Okay, and you take that patch. Now you take that oil sheet out using a graph sheet. Graph sheet, I think you know every square. What is the area? You have idea? Graph sheet mein hai na? Every small squares are there na. So that just you keep, you know that in that oil sheet there will be a patch like that. That is nothing but oleic acid patch. And what is that area of the spread you have to find out just by using graph sheet. Okay, hope you are following. Can you find out the area? Can you find out? You have idea?
Yes, ma'am.
Yeah, graph. I think you have idea na. Is it? Okay, therefore.
Yes, ma'am.
Yeah, just you keep it. With this, how much squares are being occupied here in this with the graph sheet? You find out. From that, I think you can find out readily the area. Okay, laboratory without any microscope, powerful microscope, you can easily find it out. Are you following? So with that, this is other method for finding. If microscope is there, powerful resolution, high resolve microscope, high resolution microscope is there, easy. Otherwise, this is the way. Okay, just you find out what is the area of the spread. Once you know the area of the spread, then what is the volume of oleic acid? Volume of the oleic acid will be A into T. Are you following? Therefore, Now you can find out from that experiment what you have done. What is once again volume of, you're finding one more expression for volume of what? Oleic acid. Okay. Volume of folic acid in the spread. In the spread or in the layer. Okay. And that is nothing but A into T. A into T. Is it clear? So now I think both are same only. Volume of the oleic acid in the solution is NB by 500. The same thing only you poured it on water. And once alcohol gets evaporated, only oleic acid surface is there. That surface you are finding the area. Okay. And thickness of that oleic acid, thickness of the layer spread, that gives the size of the molecular size of oleic acid. Okay. Therefore, now you know what is the volume of oleic acid is nothing but area of that layer spread into the thickness of the layer. That gives you this. Therefore, you know that 1 is equal to 2. You can equate both. Therefore, you can say that A, therefore, comparing, that is equating 1 and 2, both are same, no? A into T, that is equal to NB by 500. Therefore, you can very easily find out what is the thickness, that is NB by 500. Okay, from this you can calculate the thickness, okay, of the layer. The thickness of the layer is nothing but the molecular thick, 1 molecule thick. Okay, 1 molecule thick. From this, if you find the order is, if you find what is the order, say the experiment is done so many times and it is found that the average value of T comes to be around 10 power minus 9. 10 power minus 9 meter. The order is of the order of 10 power. The thickness is of the order of 10 power minus 9 meter. That gives you the molecular size. The molecular size of what? Oleic acid. Oleic acid. Is it clear? Whether you have any doubt in it, children?
Ma'am,
Ah.
ma'am, can you once again tell that area of the layer, ma'am? I was having network problem that time, ma'am.
Area. First you are pouring now. Once you pour here, you see pour, it will take approximately a circular patch. Approximate, not exactly circular like that. It will be somewhere. Whatever be a surface, don't bother. It is always, it won't be circular. Slightly distorted, maybe there. Doesn't matter. Because anyhow, you are not going to use, what is that? Just you take one oil sheet. Okay, in the lab, how much, how to find out. Okay, if you have a powerful microscope, you can find out what is the area. Okay, so without any problem. But if you don't have, in our lab and all, we don't have that much resolution microscopes and all. So in that case, you take one oil sheet, oil paper or butter paper, what you call it. Okay, and just what you have to do is keep it on the spread. Keep it on the spread gently. Gently you keep it. Then after that you take. Therefore, you can say that in that butter sheet, if this is the butter sheet, okay, there you will be getting, what is that one layer? Some, whatever be it, some distorted layer, whatever. That is nothing but the layer of oleic acid. Okay. Then I have to find out the area of it. Then you take one graph sheet. Graph sheet, put it at this much. How much? What is the area? Area of the graph sheet. Just you keep it. Keep the graph sheet here. How much area will be covered? How many small see, squares are there now. Okay, that you can, it will occupy how many squares? You can find out now. Small. You're just not getting me. Okay, see, like that. Okay, now once from this, I think you can find out what is the area of this spread with the graph sheet. More than that, I cannot say. You have to. It's very easy. Okay, with the graph sheet, I think you can find out what is the area of this oleic acid layer spread. Once your A is ready, okay, then T, you know that T is what we want. We are interested in finding our thickness. Why? The thickness is approximately gives you the order of the size of the oleic acid molecule. Okay, so A into T gives you the volume of the spread. And the volume of the spread, once again, it is nothing but NB by 500. That is nothing but we have taken only volume of folic acid in the solution is NV by 500. That only has spread on the lycopodium surface, water lycopodium surface. Okay, therefore you can equate NV by 500 is nothing but A into T. From that you can find out what is the thickness. Thickness approximately gives you the size of the what is the oleic acid molecule. Is it clear?
Yes, ma'am.
Shall we go to the next one?
Yes, ma'am.
Yeah. See, next one is measurement of mass. See, as I told you, tomorrow also I'll let you know, there is a workshop for us for all PGTs, Jigyasana. But because we didn't get any intimation, it starts by 9:45 at 10 o'clock only. So that is why I thought, why to waste? So 9 to 10 class, I don't want to miss. At least the 12th standard I'm missing anyhow. So I thought, okay, let me take the class. After that, I'll go and join. And so I think it starts by 10 o'clock. Immediately I have to go. Okay. So tomorrow also, if possible, if it starts by 10 o'clock means definitely I will take class. Okay. And if they start by 8:30 itself, okay, today because inauguration, so many things are there. That is why if it starts by 8:30 itself, then I cannot take class. Is it clear? Anyhow, I'll let you know what is arrangement may be made. Otherwise, I'll see what can be done. Okay. Clear? Measurement of mass. Next one, what a measurement of mass means? Mass, there are so many methods. You can even find out the ordinary, that is gravitational mass, by using ordinary grocery shop and all we are using now. We are finding 1 kilogram of sugar. Okay, so common balance is used there. That is very simple, that you know about it. But if you want to find out the mass of heavenly bodies if you want to, planets and all, it is not that you cannot, you have to adopt only which method? Indirect method. That is, direct method means just with the balance, physical balance. In our lab, physical balance is there. With the physical balance, you can measure the mass, very, very small mass, up to milligram accuracy you can go. Okay, so by using physical balance, if it is heavy, 1 gram, kilogram means ordinary grocery shop balance is there that you can write. These are all direct methods. Readily you can find out. Okay, so but there are indirect methods means you can find out if you want to find out the mass of planets and all. Therefore, you have to make use of gravitational method. Gravitational method, you know that Newton's law of gravitation, F is equal to G m1 m2 by r squared. And so by using, there is a method that you will be learning in our gravitation chapter. By using Newton's law, indirectly you are using the Newton's law of gravitation, and you can somehow find out the mass of the planets, approximate mass of the planets by using that. Okay, that is what is called gravitational method for all astronomical bodies, finding how to find the mass. And apart from that, if you want to find out very, very atomic size, molecular size masses, okay, I told you, I think 1 AMU, atomic mass unit. It is around 1.66 into 10 power minus 27 kilogram. Okay, therefore it is 1 atomic mass unit. Therefore, all molecular so not molecular, atomic and subatomic particles, if you want to find out the mass, there is one method, make use of what is called mass spectrograph. Okay, and by using this mass spectrograph, okay, you can very easily find out, see, it is allowed to, the charged particles are allowed to go inside the field region, that is uniform electric and magnetic field is there. So once they are allowed to move, they will take a path, approximately a circular path. Therefore, what is the radius of the circular path taken? That is directly proportional to the mass of the particle. So radius of the circular path, when they are subjected to, when the particles whose mass we want, but it should be a charged particle. It should be a charged particle. Only then it will get deflected by electric and magnetic field. Okay. Therefore, a charged particle whose mass is to be found out. So it is allowed to we are passing that through a region where electric and magnetic, perpendicular electric and magnetic fields are there. And what happens is readily it will move in a there is some condition for that you will learn in your next 12th standard. Okay, therefore it makes take a circular path. then you see the circular, what is the radius of the circular path? That is directly proportional to the mass. Just by finding what is the radius of the circular path, it is directly proportional to mass of the particle. Knowing how much electric field you have applied, how much magnetic field you have applied, that we have applied, you know. So how much, from that readily you can find out what is the mass of the charged particle, which is of the order of AMU. Okay, so these are all the method, measurement of mass, right? Then we will see, then my next one is measurement of time. Measurement of time means, you know that, see, how to, there are different clocks are available. Okay, therefore for measuring the time, solar clock is there. Solar clock, actually it is a sundial. I think you're very olden days we were using now. Solar clock is based on the revolution of Earth around the sun. Okay, therefore it is not having that much of accuracy. Okay, accuracy, why? Because you know that every day's period of rotation, okay, changes slightly. Okay, the period of rotation of the Earth around the sun and the period of rotation about itself. Okay, how it rotates about itself, everything, it changes. There is a day by day, day to day, there is a slight change. And if you see 1 year to other year, how Earth is revolving around the sun, 1 year to other year, slight changes there will be there. But that cannot be found out by using this solar clock. So it is not that accurate. But I want a clock which is highly accurate. Accuracy level is very, very large. In that case, next one you can go for, you can say that quartz, what is a quartz clock, crystal clock. That will give you accuracy 1 by 10 power 9 seconds. Just you see. Okay, 1 divided by 10 power 9 seconds. Therefore, 10 power minus 9 seconds of accuracy. Okay, so it is really very good. Okay, so this quartz crystal clock is high. It is very much better in measurement of time. But even better than that is one more. It is what is called atomic clock. It is what is called atomic clock. Okay, what is an atomic clock means? What is the principle of working of it is based on? The principle is based on, say, there is one atom, what is called cesium atom. It is based on all the atoms. You know that the atoms, they won't be, they will be arranged in their lattice, and the atoms won't be always at rest. Atoms will vibrate about its mean position, equilibrium position. They won't move from one place to another place, but all the atoms will be vibrating about their mean position. If atom is here, means it will be vibrating always. Why? Because it is having some energy. What energy? A thermal energy. So outside the temperature is there, not room temperature. Therefore, what it will absorb that energy. That energy is enough for the atom to, with that energy, what it will do? It will vibrate like this. Okay, so now this atomic clock, what is atomic clock? It is based on that principle. What is the period principle of? And you know that vibration, half a odd manner, it won't vibrate. For vibrating one full vibration, if it is starting from here, it is starting from here, and it goes, it is and it goes here, coming here, goes here, coming here. So for that, the time taken will be a constant. It is periodic vibration. Is what is called period. It cannot, for one vibration one time, the next vibration the some other time it won't take. It is periodically. Every vibration, completing one full vibration, takes exactly the same time. That is why it is called periodic vibrations. So the cesium atom, it vibrates periodically, and from that period of vibrations of cesium atom, okay, the atomic clock is derived. Okay, that is why it is also called cesium clock. It is also called cesium clock. Okay, therefore, these clocks are very, very accurate. Accurate, what is accuracy now? The accuracy is of the order of 1 by 10 power 13 seconds. You see here, the previous one is quartz clock, quartz crystal clock, whose I think I have given you. First one is quartz crystal clock, whose accuracy is 10 power minus 9 seconds. I told, but I have not written. Okay, therefore 10 power minus 9 seconds. Next one is atomic clock. Atomic clock, whose accuracy is of the order of 10 power 10 power minus 13 seconds. 10 power minus 13 seconds, which means that it very accurate. It won't change at all with respect to the rotation of the earth. Nothing. It won't affect that much. Okay. So if at all there is any change, 3 microseconds are less than that in 1 year. Okay, 3 plus or minus 3 microseconds, maybe that too. Okay, that much in 1 year. Just you imagine, microseconds, that much in 1 year, if at all there is some variation, or if only that much accuracy it has. Okay, that is why. So this is that cesium clock is very important. This clock only we are maintaining in finding IST timings, no, Indian Standard Time. IST, Indian Standard Time. Who is maintaining? You have any idea? IST time is maintained by what is called NPL, National Physics Laboratory, which is at Delhi. NPL. Okay, National Physics Laboratory. They are using for maintaining IST. Okay, IST, that is Indian Standard Time, is maintained by what is that? National Physical Laboratory at Delhi. How are they maintaining the time? Only by using this clock, cesium clock. So just imagine. So they are, therefore the time is whatever we are given by IST is that accurate of the order of 10 power minus 13. The accuracy is to that order. Okay, so we are using that, right? Next one. Let us go to the very large measurement of very large time. Long time measurement, long intervals. Therefore, how to find out? Can you tell me any one method? Very long time. I think, have you heard about carbon dating? Why all are sleeping here?
Yes, ma'am. Yes, ma'am.
Carbon dating. That is what is called radioactive dating. Radioactive carbon dating. Okay, so that is used. Okay, and you can even find out the time intervals of the order of 10 power 17 seconds. Find out how many years, 10 power 17 years afterward. Okay, so 10 power 17 seconds, how many years you just see. Okay, therefore, now you see from this carbon dating, you can find out so many old, what is that, age of fossil rocks, age of earth, okay, and all the materials, very old materials, what we are digging, and very Mohenjo-daro, Harappa time and all, even before that, what and all are there, no, everything. How to find out? It is in this period, it is from this period, this sample we have got, it is the age is this one, like that they are binding, only by using this carbon dating. Okay, so you can even this is used for finding very long intervals. I think